in the nature of light. So what is a wave? A wave is the transfer of energy, usually in the form of a disturbance from one place to another. Specifically, a periodic wave, or a continuous wave, is a wave with regular or periodic disturbances. There are different parts to a wave. The bottom is called the trough, and the top is called the peak. These two combined are called a pulse. So what are the different types of waves? First, we have mechanical waves. These are waves that need a medium to travel in. An example of this is sound. This is why we do not hear sound in space. Secondly, we have electromagnetic waves. These do not need a medium, and that is why we can get light from the sun. Particles and waves move in many different ways. There are 3 types of particle movements. 1, transversal waves, 2, longitudinal, and 3, surface waves. So let's say as a whole this wave is moving towards the right. However, since this is a transversal wave, each particle moves perpendicular to that motion of the wave as a whole. In a longitudinal wave, each particle moves parallel to the direction of the whole wave. So in this case, the particle would be moving to the right as well. Finally, we have surface waves. In these waves, the motion of the particles are circular or elliptical. It is a combination of transverse and longitudinal waves. The particles circle when at the crest and flow between crests. A wavelength is either measured from crest to crest or trough to trough. Longitudinal waves are different than transverse waves and surface waves. Longitudinal waves move by compressing and expanding. Basically, they move like an inchworm. Compressions are regions of the waves where particles are closer together, and rarefactions or expansions are regions where particles are separated. Next, we have some new formulas. Velocity is the speed that a wave travels. There are a few formulas you could use. V equals length over time, or V equals wavelength times frequency. The relationship between frequency and period is inverse. So T, or period, equals 1 divided by frequency, or frequency equals 1 divided by period, or T. Next, we have nodes and antinodes. So a node is the place where the amplitude is 0, and an antinode is the place where the amplitude varies from 0 to the maximum value. So here's an example of multiple sequences. What happens when 2 waves meet? This is called interference, and there are 2 options. Constructive interference happens when 2 waves meet and their amplitudes add up to make one greater one. This is like when 2 small waves in the ocean come together and make a bigger wave. Destructive interference happens when 2 waves and their amplitudes subtract, and the amplitude is now 0. So in this example, the peak would meet the trough and create a 0. Diffraction is the spreading of the waves around an object, so this is very different than constructive interference and destructive interference. An example of diffraction is if 2 people are in separate rooms separated by a slightly open door. They can still hear each other because the sound waves go around the door. So what's different about light is that it is both a particle and a wave, and this is called the duality of light. Thanks!